Alright, I've got the bar top actually on the countertop because working on it while lying on the ground was a pain in the neck. Um, so, what I've done, I'm pretty close to getting this thing actually up and running. I changed the joystick out from what I was trying earlier. I was trying a Seimetsu. This is a Sanwa. I didn't know if it would fit. Because I modified this Sanwa's mounting plate for a different control panel, it looks like it fits with the exception of this one bolt here. Really doesn't fit very well. So I think if I enlarge a couple, if not all four of the bolt holes a little bit, I think that'll sit flush. So I'm not too concerned with that. My other concern was this. This joystick has all 5 inputs come through this ribbon cable instead of 4 individual switches that each have a ground wire and a signal wire. This routes them all to one wire, and I was worried it wouldn't fit. But it closes absolutely fine with the plexiglass in there, and it doesn't touch anything. So it's just the right size to work. So I think I'll be sticking with this joystick. I have a friend who I'll loan or sell, if they work, I guess, the joystick that was in here, because I have a pair, and he's got a Neo Geo cabinet, and he's looking for some different sticks. So anyway, so we've got the joystick in there. We've got these 3 buttons in there. Nothing's wired up in here yet. And then we've got 2 original buttons because there are extra holes in them. There's a round hole in the panel, and then there's 2 really small holes on either side that are for alignment pegs on these black buttons. So I thought I'd just go ahead and put the original buttons back. I also have these switch holders have light bulbs on the end, so those actually can light up if I decide to route voltage and a ground to the 2 outside connectors on this switch holder. So these 3 connectors are for the switch. You'd use the ground and the normally open, and then here you'd use a 5-volt and a ground, one on either side, to power the bulbs inside the buttons. Next in here we've got these 2 buttons, which basically, obviously, you can only get to when you unlock and open this panel. So for emulator setup, I'm not sure what buttons you'd want to use only when you pull the panel down. It'd basically be something that you hardly ever use, or you don't want other people to use, like if you don't want a combination to get into the menu to make changes, instead of left on the joystick and one of these buttons or something like that. You can make hard assigned, I'm guessing, one of these 2 buttons to get into the menu system or something like that, but they're there on that bar, so I just kind of hook the connector up to them, which goes out the side and has the wires and a ground, and also the coin slot switch, because this hole is where the coin slot goes. I'm still not exactly sure what the bridge rectifier on this metal frame actually does. It's coming off, looks like secondary wiring on the isolation transformer, which is down there, and then the wires go to a 4-pin connector, and from there 2 wires go to the board set, and the 3rd wire, I think, goes to the control panels. I think it might go to the buttons, I'm not sure. And I think I traced out that one of the lines that goes to the board is green. I think it's ground, and then the other one I think goes to the audio section of the board. So this might be producing 12 volts for the board's audio section, but why would you do that if you've got a switching power supply in here that provides 12 volts? I'm not exactly sure. I haven't found schematics for this online. I haven't really looked. But I'm thinking I might, when I power this on, I might put my multimeter between the 4-pin connector has one green wire, and then it has 2 pins with black wires. So I might put my multimeter between the green and the black wires and see what's going on. See if it's just voltage that for some reason they're pulling off the bridge rectifier instead of the switching power supply. And if it is voltage, then I could probably use that 4-pin plug and plug them into these so these buttons light up. They'd always be lit. They wouldn't be controlled by the Pi or anything, but you know, the buttons are there, the light bulbs are there. If the power is there, you know, fairly simple to wire those up, so we'll see. The reason I have the coin slot out is because you can get monitor access, including, if you can see up there on the right side, there's the pins for the input to the monitor, the video input, and this is the best angle, I think, to be able to plug stuff in, because there's just stuff in the way if you try to go through the back door. So I think this is the way you want to go to plug in stuff to the monitor. You can see the speaker there, which is mounted with 2 screws on kitty corners, and it's raised up a bit above this metal box enclosure that holds the coin box, and that's the slot where the coins drop from the coin mechanism. And then back around here we've got our power switch, we've got our breaker, which I'm hoping that the Raspberry Pi, the audio amp, and the monitor don't draw enough power to trip the breaker, because then I'd have to figure out what to replace that with, trying to find another breaker that's allows more current, or to put a fuse in there somewhere. Then what we've got is this right here. This comes from this assembly. This whole assembly pulls out, and it's got the line goes in, it goes into a line filter, and then the breaker and the power switch. There's also in this area, if I go down here, there's a coin meter that I got just disconnected. So this is your AC from the wall, goes through here and comes to here. Normally on the cabinet, it plugs into this connector. This connector went to the switching power supply, so you've got your field ground and your 2 AC lines went in here. I have changed them to go to this 3-pin connector. So originally they went up here, and then the wires were doubled, and then they went back to the transformer. And you can see this example here, the field ground still is the same configuration, 2 wires going to the switching power supply. The reason I did this is powering the Raspberry Pi, so I'll get to that in a minute, but normally these wires would be up there attached to the switching power supply. So then they went back to the transformer, and then off of the transformer you have the connector here. This is the 2 pins AC for the monitor that comes out of the isolation transformer, because this monitor requires an isolation transformer. So that's your power in to your monitor. Then it also goes to this fan. So this is an AC fan, and one of them, of the 3 of these cabinets I got, was just, this thing just was totally loose, and the internals of the motor were totally seized. This one spins really freely. The other one is tighter than this but does spin. So this is the best looking of the 3 fans. I have not applied power to this one or the other one. I threw the broken one away. but I'm just guessing that this is probably the best of the two that I kept. And then inside on these rails went the original circuit board, and then all the wiring that went to the circuit board has been removed. So you had a speaker connection, which is this one here, 2-pin speaker connection. You've got another 2-pin connector up there that goes to the coin meter that went to the main board. There's another 2-pin connector. No, there's not a 2-pin connector to the coin switch. For some reason, the coin switch is hardwired, which is a pain in the neck because you pretty much have to pull it out of the cabinet to pull these wires off because they're on really tight, instead of reaching in the back and finding a 2-pin connector. So that's about all that's going on in there now. The main wiring harness has been removed. That has all the buttons went to connectors that went to the motherboard, and like I said, the things up here, some 2-pin connectors went to the motherboard as well. So that's all been removed. The switcher, like I said, probably will be removed. Definitely can be removed if my solution to powering this works, which I'm sure it will, which I will show you now. So, like I said, normally the AC lines come up to the switching power supply and then into a connector where the other side of the wire goes back to the isolation transformer, and I moved them to this. Now, why I did that is powering Raspberry Pi. The Raspberry Pi normally is powered through a USB micro plug and a power supply, such as this. Now, that's the normal, it's, I think, one of the most common ways to power it. Now, you could also power the Raspberry Pi by soldering the positive and negative wires from that cable to the USB plug on the Pi board. So I'd have to take the case apart, cut a hole there by my thumb. You can see the micro USB power input. You could solder it to the board directly there and have the wires come out the case there. That's one way to power it. Another way is through 2 pins on the GPIO header, but that pin header has this RGB-Pi hardware on it. It does have 5-volt and ground, so I think I might be able to, again, take a 5-volt source and just with bare wires solder 5-volt and ground to this. But if you do that, it bypasses the built-in poly fuse on the Raspberry Pi for voltage protection, so I didn't want to do that. So the best thing I could think of is to put this whole thing in the cab, powering it with AC. So if you look at this, it's not a 3-prong plug. It's 2 prongs that are the same width, so it's non-polarized, so it doesn't matter if you plug it in this way or this way, it'll still work, so that's good. So what I did was I took the AC wires that go into the switching power supply, and instead of taking 5 volts from the power supply and routing it into a micro USB connector to the Pi, and then adjusting the dial here to the right voltage, and usually in my experience when these power supplies fail they just stop producing voltage, they don't ramp up the voltage, but didn't really want to mess with having a voltage adjustment in here. So this now goes to this is a $3 and something cents. I rounded the change up to charity or whatever at the hardware store. So $4 for a light use extension cord, 2 plugs that are covered with a plastic cover here, and 1 here. And you've got the hot and neutral, so one's wider than the other, but like I said, that power supply, it doesn't matter which way you plug it in. I did, however, look online because I can never remember, but the white wire goes to the wider of the two sockets there. So I wired this up so when connected to this, the white wire of this 3-pin connector will go to the correct pin on this. So if I end up with that power supply failing or not being strong enough to power everything, which again I'll get to in a second, then maybe if I get a different power supply, it will require the correct polarity. I made sure that I've wired this up so it will receive the correct polarity from this outlet here. I cut the cable. It's like a 6-foot cable. I cut it this long, which is probably too long, but I'd rather have it too long than too short. And the extra cable can sit in there. It's fairly flexible. And just used Molex pins. I had some made for thick gauge wire. I'm almost out of those, but had enough to crimp them on here. Worked really good. And then the same thing here. Oops, sorry. Here, I keep pointing to this one, which is has the field ground in the middle. This is the one I'm going to use. This one has the 2 wires like this that were doubled up that go into, again, 2 Molex connectors that are made for thicker gauge wire. So it was able to properly crimp 2 wires. So this will plug into that, and then the Raspberry Pi power supply will plug into it and power the Raspberry Pi. So if we go on to the next thing, I bought a 5-volt Noctua fan. So Noctua has these. This is a 40 millimeter 5-volt fan, so it's nice and quiet, moves a decent amount of air. This case that I printed, I got off Thingiverse. It's got slots in the bottom for airflow, but I don't know how much of that airflow can go around the PCB and up through the top. And the guy that designed this case with the opening for the 40 millimeter fan, there's 2 slots here. There's one there and one over here over the ribbon cable input slots, or input output whatever slots on the Pi, and that's it for airflow. So I might drill some extra holes in the top of this, but looking at it, it would probably get enough airflow through this opening. I had to cut this opening to get the RGB-Pi to sit on there nicely. It'll probably get enough air in there. Plus I plan on putting Velcro on these 4 pads, so it'll be sitting up a little bit in the air. But you can see how these ports here are fairly tight, so not a lot of airflow to get in. So I've got it blowing the hot air out right now. And then the fan also, and I have some models that don't. I got one that has a USB adapter and the other one didn't. I thought I ordered both from the same quantity, 2, but ended up with 2 different fans, but that's not a big deal. But yeah, it's a 5-volt fan, and it comes with an adapter for USB, so I plugged it into the Pi. So it's powered by the Pi to the USB to the fan for 5 volts. This is a 32 gig thumb drive that I had on hand that I've got the games on. It really should be more like 64 if you're going to fill it with all the games that the RGB-Pi folks have set up to work with this hardware, but this is what I had on hand. I did order a 64 gig micro SD card, but then I changed my mind about using it simply because if you read the documentation, the OS formats the card in a non-PC friendly format, so to do any work with transferring games, you have to remote into the Pi and FTP them, and that's not a huge deal. It's just that if you use an external device, it is FAT32. So you just unplug this, put it in your PC, and change the games, add, remove, whatever, and then plug it back in. So I thought that was a lot more convenient way to do it. And since this whole thing, even if it works and looks great, I don't know if I'll just say, hey, that was a fun project and take it apart, or keep it, or sell it, or what. But just decided I've got a spare 64 gig card. I put an 8 gig card in the Pi with the RGB-Pi OS on it. And that pretty much covers the Pi other than audio. So the Pi has stereo audio jack. So I've got a cable here that goes into this. I believe these were $15 for 2 on Amazon. It's a little stereo amp. Excuse my cranky old cat. She's okay. She's just that way. So the stereo from the Pi will go into this amp. It's got stereo out. Right now I've just got the left channel hooked up just because this is the speaker cable for the one speaker in the cab. I can set it to left and right because I'm betting that the Raspberry Pi for games in stereo, I'm betting it probably outputs in stereo, so I might be missing a channel for games that are output in stereo. So I might tie the left and rights together, but again, this is just to get it running now. And it also has power. It needs 5 volts power, and it just comes with 2 screw terminals to screw a wire to. This is obviously the volume adjust. So I had this old USB cable. I did not cut it short because I wasn't sure if it was going to work. But I stripped the wires. It's a full USB 2 cable, so it's got 4 wires in it. The typical colors are red for the red and black, red for the 5 volts positive, black for the ground, and then a green and white, which are for data transfer. Some cables for charging a phone might only have red and black. They don't have the white and green because they're just for charging and not for transferring data. This one had all 4, so I just cut off the white and green flush and then passed the 5 volt and ground. And then the other end plugs into the Pi as well. So the Pi has a fan and the audio amp and the 32 gig card. And I'm hoping that this 2.5 amp power supply I have is strong enough to power all of that. The AC, like I said, because I've chosen AC and not the switching power supply, AC will just power this outlet, so that's not going to be an issue. It's just going to be, is the draw. Basically, I'm kind of worried about how much power does this audio amp draw. I didn't really see online how much it draws. The fan is a negligible power draw, but this might be more. So this then is for buttons, and this is for video. So I've already done a test. I can't remember now if that was in one of my videos or not. Yes, I had a video where I was running the Pi to the monitor, so that was through these video cables. And then I also had this hooked up to some buttons. This is like an old harness from a Xerox high-speed printer that I got. Place where I worked was having some repairs done to one, and they were tossing the wiring harness out, and I thought, hey, asked them, can I have that? And so, yeah, I've kept it for years, used it on a couple main projects, but it's just a fairly thin wire that has a connector on the end that will enable a bunch of wires to pass through, so I decided to use that for this project. So you've got buttons, you've got video, you've got audio, you've got cooling, you've got your games, and the operating system's on the micro SD that goes into the Pi. So that I all had running on the floor, no monitor, but all of what you see here, I had an extension cord to the wall to power the plug, and then I had the amp plugged in, stereo cable plugged in, didn't have any video or buttons plugged in, but I was testing, does it have enough power to boot, and does the amplifier work? And I did get sound out of it. I heard the booting sound of the RGB-Pi Plus when it came up, and then it's also got, along with the screensaver, it plays some electronic music when it goes into screensaver mode. And I heard the music, and I was able to adjust the volume, and it didn't sound too terrible coming from that little tiny speaker. It sounded all right, about what I expected, so that was good. Now, what did happen when I first powered it on, it came up and it booted, and I didn't hear anything, and then it shut down, and then it booted up again. And then I heard the boot sound and the electronic music. So I'm wondering if that's because the Pi detected that I had added either or the fan or the audio amp and the audio jack to it since the last time I ran it. So that's what I'm thinking, is maybe the Pi was aware, hey, there's now something plugged into the audio jack, and it maybe updated a setting and then rebooted itself. I hope so. I turned the volume up pretty high and it didn't reboot again, so I was worried that maybe it was drawing too much voltage and that's why it booted, and it still could be. It could also be that my power supply they're fairly cheap, that my power supply isn't very good, isn't good enough. But I'm just hoping that it was because it booted up with the audio device on it for the first time and it rebooted to update some settings or something. Because I did not have a monitor hooked up to it or buttons, I couldn't start a game. So that'll be the true test, is to actually run a game. So the CPU is actually doing a lot of work while the audio is going. That'll be the true test if it shuts down or something like that. It shouldn't get too hot, I don't think, with that fan on there, and hopefully this fan works. It also is set to blow hot air out of the cabinet, so hopefully things won't get too hot. So my main issue that I'm worried about is power. If I do have a power problem, then what I might have to do is change this around so that I am going back into here, and the switching power supply will power the Raspberry Pi and the audio amp, or because this power supply has 3 prongs available, 3 plugs, I could find a 5-volt power supply similar to the Pi one. This Pi one is 5 volts, and then cut the end off and then run the positive and negative voltage from one of these into the audio amp. And so the Raspberry Pi will have one adapter on this side, and then the audio amplifier will have an adapter on this side, which I think I like that idea better, just getting that switching power supply out of the cabinet. Not that it looks like it's going to actually be in the way, because there's not that much that needs to go into this cabinet, but I think I like it cleaner with that switching power supply out of there. So that's it. That's kind of a video. Like I said, this tested working, booting up, playing the background electronic music tune so that I know that it all works in the configuration that I have it. So now I just have to wire the controls up to the other end of this so I can plug the controls in. I need to plug the monitor in. I need to plug this into the 2-pin speaker from the cabinet. Put this back in. Put some Velcro or something on the bottom of this so it's not touching the cabinet bottom, because the reason this thing weighs 60 pounds is this whole thing is lined with metal. The top panel is metal. So this is metal. The coin box here is metal. Everything is galvanized steel in this thing. So I don't want the bottom of this thing, the solder points there, to short out. So if I put some Velcro on it, then I could stick it somewhere in here. It might even be an idea for me to cut a round hole in here, mount it here, and then you'll have the volume pot hopefully sticking out the back of the cabinet, and you can adjust it from the back. But again, am I going to keep this when it's done, or is this just another one of my projects just to go, hey, look, that worked, that was cool, now let me take it all apart, and because I'll never use it. Yeah. Again, sorry, our kitchen's a bit messy. I'm trying not to show too much of it. And obviously this is not going to live here on the kitchen counter. I would not get away with that. And again, an issue I've got is the angle of this control panel is kind of, you're going to have to sit to play it somewhere, and other than right here, where do I have that's high enough that you can sit in a chair and have your angle be good enough where you're not like I am right now, where it's just that would be horrible to play it like this because you're not looking straight on at the monitor and your hands too cranked back. But anyway, that's where I'm at now, and hopefully by the end of the day, in fact, even not too much longer, I can get it up and running. This monitor has not been tested. Let me go there. Half an hour. Trying not to ramble too much. Try and get this to end here. This monitor has not been tested. This is a Wells Gardner, the same as the one that I was testing in the other video. The other machine I took apart, totally stripped, and took all the parts out. That monitor is a Hantarex, and it's got some kind of fold-over issue, and I have never worked on a Hantarex. I don't know if it's just a cap kit or something else might be wrong. I'm betting these monitors have never had a cap kit, and they were made in like 1990, 91-ish. So, yeah, I'm not sure what it's going to actually look like. I'm hoping the monitor is going to be as nice as the other Wells Gardner. There's like, you got to look really close. You can see a little bit where it says Pit Boss at the top, and then there's an area down here that you can see a little bit of something, the burn in. But it's really, when you're playing, you can't see it. So I'm hoping that this monitor works, although I think the boards that were in here had a wider resolution, so I might have to get to the width coil, which means flipping this thing on its top to get the monitor out, to get to the width coil to make adjustments, which is just another silly thing about this setup. It's just not, it's not very friendly for working on it, especially the monitor. Although I'm not sure if a bar top cabinet would be much different if you had to do something like the width adjustment. But hopefully when you do a width adjustment in an emulation setup like this, it's something that you hopefully would only have to do once. So, okay, I'm going to cut the video off there. The tested working Pi system needs to go into the cab. Video, audio, everything plugged in. Probably leave the back still folded down. Plug it in, flip the switch, and cross my fingers.